So good evening guys, welcome to NEET World Institute and the NEET World YouTube channel, right? So as you know that this series is for EAPCET aspirant in both medical as well as engineering stream, right? For upcoming year like 2026 examination, okay? Like it's going to happen in the end of March and the starting of April month, right? Okay, or in the like in the span of March to May month it will happen, that EAPCET examination for both Andhra Pradesh and Telangana, right? So for yes, for both the medical and engineering stream, right? So in this session now we are going to discuss particularly about physics, right? Yes, like our NEET World Institute, no, like YouTube channel, right? We are focusing on every subject like botany, zoology, mathematics, chemistry, as well as physics. Okay, so in this session we will focus on the physics class. I mean physics chapters, right? So in last class we were discussing about the chapter work, energy, and power. Like we just started the chapter. Okay, so whoever have not like seen the class, no, I mean attended the class, no, you can see the video lecture of the last class, so that it will be it will be understandable for you guys whatever going on in this class. Okay, so let's wait for 1 or 2 minutes, like the people over here joining. Yes, we'll wait for another 30 seconds, like people are joining over here, right? Yes. Okay, so let's start the class. So we were discussing about the chapter that is work, energy, and power. So basically we are started with the topic work, right now. So what is the meaning of work and what are the formulas we have studied, right? So we have studied the formula W is equals to F dot S, whereas I can rewrite this as Fs cos theta, right? So if theta like is between 0 to 90, no, 0 to 90, it is a positive work we have told. If it is 90 to 180, it is a negative work. If it is exactly easy, it will be equal to 90, it is a zero work, right? So these are the major thing we have seen in the last class, and included that scalar properties and vector properties also we have seen, right? So the basic need of this chapter is scalar and vector, right? So if you know the basic of scalars and vector, this work energy power will be easier to analyze, like the questions whatever they are asking will be easier. Okay, so this is for the constant force, like the force has been applied constant, like so the work done will be W is equal to F dot S or Fs cos theta. Suppose yes, before that let me conclude this one. Okay, so SI unit will be SI unit is Newton meter, I can say, or joules. Okay, this is the basic things we need to know about the work. Okay, now variable force. So the formula will be integral, like, let me write the direct formula. W is equals to integral f dot dx or ds. Okay, f dot dx. So dx, like, from x1 to x2. So this is the formula for the variable force. Okay, this is the formula for the variable force. So what is the assignment of this work done by the variable force? Yes, it's the same SI unit, right? Yes. So same SI unit will be there, and then if they are mentioning that like whether it's work done is a scalar or a vector, so it's a scalar, because when I talk about two vectors are having a dot product in between them, I'll get a resultant as a scalar. Okay, so this is the main thing. Now can we do the problems based on this? Okay. Okay, so let me tell you the problems. Okay, so these are the like problems of the EAP sets. Okay, EAP sets only. Now the first question is, let me read out the equation. Okay, a particle is displaced from a point A 1, 2. So from a point A, that is 1, 2, to B, that is 3, 4. Okay, so this is 3, 4. Okay, so a particle has been displaced from a point A to point B, having a points, that is 1, 2, 1, 3, 4. Okay, so applying a force F is equals to 2I cap plus 3J cap. Okay, so find the work done by F to move a particle from 1 to 2. So they are asking what is the work done by the particle from point A to point B. Okay, so suppose this is my point A, like let me consider, okay, by not drawing the graph, like if I draw the graph, if I plot that point, it will be different. Okay, so I am taking a line like this. So this is my point A and this is my point B. Displacement is nothing but B minus A, like change in position, right? Final position minus initial position, right? So displacement, right? So I know the formula for the displacement, and I know the points, like it's 1, 2 and 3, 4. So if I adding a point 1 and 3, I can say either it's x-axis, y-axis or z-axis, right? Fine. So they would have mentioned that a particle is going in x direction, a particle is going in y direction, a particle is going in a z direction, like that. Okay. Now they have mentioned that 1, 2, 3, 4, and they have given that it's in a xy plane. Xy plane in the sense like the plane will be having I cap and j cap. So which means I can say that A is nothing but, okay, I plus 2j, okay, sorry, I plus 2j, and B is nothing but 3I plus 4j, right, 4j. Now displacement S is equals to 3I plus 4j minus I minus 2j. This is my displacement, right? So what happens? I cap and I cap, I should take common things, and j cap separate, So 3I minus I is 2I cap, 4j minus 2j is minus plus 2j cap. So this is my displacement, right? Now the force they have given. So work done is nothing but force into F dot S. No, what is F here? 2I cap plus 3j cap dot 2I cap plus 2j cap, right? So this is my work done, like 2I cap into 2I cap means nothing but 4, 3 into 2 is 6, so answer is 10 joules. So this is my answer, and this is how we will proceed with these kind of questions like the points has been given. Okay, so let me give us some other question here. For example, I am giving a point is moving from P to Q. Okay, P is having points like 1 comma 3 comma 5 to Q is having a point, it is 2 comma 4 comma 6. These are the points. Okay, and the force is applied here is like, let me take, this is 3I cap plus 7J cap plus 9K cap. Okay, 9K cap. So this is my force and these are the points. So what is the, let me write the question. What is the work done to move a particle from P to Q? So this is the question. Okay, so can anyone give answer for this question? Like who are watching in online, no, they also can give answer in the comment boxes. Guys who are watching in online, they also can give answer in the comment boxes. So what is the answer for this question? So what is the answer? Got it? Okay, let's find the answer. Okay, so if I consider P is nothing but I cap plus 3J cap plus 5K cap, and Q is nothing but 2I cap plus 4J cap plus 6K cap, and they have given F also. So work done is nothing but work done is equals to F dot S. Before that, I need to know the points. No, like P minus Q will be displacement. So displacement is nothing but 2I cap plus 4J cap plus 6K cap. Sorry, this is K cap. Okay. Yeah, okay. So 6K cap minus I cap plus 3J cap plus 5K cap. So 2I minus I is I. 4J minus 3J is plus J, 6K plus minus 5K is plus K. This is my displacement, right? Now force is given as 3I cap plus 7J cap plus 9K cap dot I cap plus J cap plus K cap. So 3 into 1, 3I dot 1I is nothing but 3 plus 7 into 1 is 7, 9 into 1 is 9. So 16 and this is 19, right? 19 joules, or I can say it is 19 Newton meter. This is the work done. Okay, this is how we will do the question when the points are given in I, J, K, like 3 axes, like x axis, y axis and z axis. Okay. Done. Can we go for the next one? Okay. So next one, like we have discussed about the variable forces, right? So variable forces, before going into the problems, let us discuss about some points about energy. So what is the meaning of energy? So you are doing some work, no? Like how you are doing that work? If you have energy, only you will be able to do that work. Obviously, right? And the thing, like, yeah, you have fallen sick. Okay, you got sick, and a person is very healthy. Okay, and if I talk about these two persons, they will have different kind of energies. If I ask that energetic person to run for 10 kilometers, he can. But a person who is having a fever or got sick, if I ask him to run for 10 kilometers, will he able to? No, right? So that depends upon the things. No, like he has completed the work because he has some energy. He doesn't have energy, right? Okay, so I can say that the capacity to do work is known as energy, right? Okay. Energy is nothing but capacity to do work, right? No, capacity to do work. So when we talk about the energy, like different kind of energy we were discussing in day-to-day life. Like for example, sound energy, heat energy, and in lower classes we have studied about the potential energy, kinetic energy. Yes, no, like many kind of energy you have studied, right? So in this particular lesson, we will discuss about the kinetic energy and then potential energy. Okay, and one more energy, that is spring energy. Also, we will discuss spring energy, like how much the work has been done by the spring, what is the forces applied on the spring, how much it has been displaced, everything we will discuss. Okay, the main important thing is kinetic energy and the potential energy. So first point is this one, like the capacity to do work. Okay, fine. Second point, types of energy we will see. So one is kinetic energy and one more is potential energy. Okay, so this energy, when an object are in motion, okay, and this energy we can easily say like a stored energy. Okay, these are the two things, like kinetic energy and the potential energy. This sum of this two energy, sum of these two energy is called as mechanical energy or total energy. We will say mechanical energy or total energy. Okay, so next point if we discuss, that is SI unit of energy is joules. The same SI unit as work done. Okay, so instead of this work done, we can use this energy formulas. You will be having some doubts in some questions how we can use. Yes, we will see such type of questions also in upcoming sessions. Okay, in upcoming problems also we will see that. Okay, now we will see the formulas for this kinetic energy and the potential energy. So kinetic energy formula is of mv square and the potential energy formula is mgh. So if I talk about here, m is nothing but mass, v is nothing but velocity, g is nothing but gravity, acceleration due to gravity, and h is nothing but height, where the object has been taken from the surface to the some point. Okay, and remaining thing, that's it, no? Yes. So this is the thing. Okay, and when we talk about the kinetic energy, there is another important point, that is kinetic energy kinetic energy in terms of momentum. So when we talk about this momentum, what is the formula for this momentum? Mass into velocity. Okay, so I need kinetic energy in terms of momentum. How can we get? So kinetic energy is nothing but 1 by 2 mv square. So here if I see m power 1, v power 2 is there. I need anyhow some m. Okay, what I should do here? 1 by 2 m square v square, okay, into 1 by m. I have multiplied by m and divided by m. So what I can say here is 1 by 2 mv the whole square by m. What is mv? That is p. So 1 by 2 p square by 2m I can say. So kinetic energy in terms of momentum is nothing but p square by 2m. Okay. So this is one of the important formula when we come across the kinetic energy and the momentum relationship. Okay. Samya, good evening. Okay, so let's go for the next one. So now kinetic energy will be equals to p square by 2m we have written. So I can say that p will be equals to, like p square will be equals to 2m into kinetic energy, and p will be equals to under root of 2m into k, that is kinetic energy, right? So this also we can write the formula. Okay. So any doubt in this now? It's clear, right? Okay. Can we see some? So there is a problem here. Okay. We'll see that problem, how we can tackle that. So kinetic energy of a body increased by 21%. Okay. Kinetic energy of a body increased by 21%. Okay. So what is the percentage increase in magnitude of linear momentum of a body? Magnitude of linear momentum of a body they are asking. Okay. So increased in the sense, how can I say that, like increased 21%? So initially some amount was there, like we take that amount as 100 and now it has been increased by 21%. Like 100% was there, now it has been 21% increased, which is kinetic energy initially will be equals to kinetic energy at second time, like the final time will be increased by 21%. This is the thing. This is how we'll write now. So 100% in the sense, okay, fine, that is 100 by 100 only we will take, right now. So increased by 21% in the sense 121 by 100, no, yes. So this is 1 by 2 m1 v1 square will be equals to 1 by 2 m2 v2 square into 121 by 100. That's it. Fine. Now, if I talk about this mass, no, mass will be always equal. Will mass change? M1 will be equals to M2. Okay, M1 will be equals to M2. So I can take this 1 by 2 out, and here let me take this M1 and M2 also. So V1 square will be equal to V2 square into 121 by 100. Right? So here V1 will be equals to under root of V2 square into 121 by 100. So this 121 and 100 I can rewrite as V1 will be equals to V2 square into 11 square by 10 square. It is under root. So root and this 2 will get cancelled off. Right? No? So what happens? V1 will be equals to 11 by 10 V2. 11 by 10 V2. Now, can I multiply this m here, m and m here? Which means P1 will be equals to 11 by 10 P2. P1 will be equals to 11 by 10 P2. So, P1 by P2 will be equals to 11 by 10. 11 by 10. They are asking what is the increase in percentage. So, P1 by P2 minus 1 will be equals to 11 by 10 minus 1. Is that fine? Is there any doubt? I have taken here m and m, like multiplied here also. If I cancel, it will be same thing. And here minus 1, both the side I have added. Okay. So P1 minus P2 by P2 will be equals to 11 minus 10 by 10. 11 minus 10 by 10. So which is nothing but P1 minus P2 by P2 will be equals to 1 by 10. 1 by 10. So this is the answer, right? Like how much they are asking, percentage. In the percentage they are asking, no? So P1 minus P2 divided by P2 into 100 will be equals to 1 by 10 into 100 percentage. No? So 0 and 0 will get cancelled. 10 percentage is the answer. 10 percentage is the answer for the given question. Okay? Got it? So you can take a note of this and we can go for the next question. Okay, done. We'll go for the next one. Done. Done. Okay. We'll go for the next question. So the next question, yes, the next question. So the next question is, a force F is equals to a force F is equals to 0.5x plus 10 0.5x plus 10. So here F is in Newton and x is in meter. Calculate the work done by force during the displacement of a particle from 0 to. So x is equals to 0 to x is equals to 2 meter. So this is the question. This is the question. So when I talk about here, it's a variable force, right? If I substitute the value of x here as a 0, 1, 2, the force will be keeps on changing. So what I should do now here, I should integrate with respect to dx. That's the formula we have seen. So first, like there are three types of things. Okay, we have discussed the first one. This is the second one, and the third one we will discuss. Okay, so work done is equals to integral f dot dx. So it is integral 0.5x plus 10 dot dx. From where to where? So 0 to 2. 0 to 2. So this is my x1 and this is my x2. Right? So if I integrate this term, how much? 0.5 x square by 2 plus 10x. So 0 to 2. Upper limit and lower limit. So if I want to calculate this one, upper limit minus lower limit I should do now. First upper limit I need to calculate. So 0.5 2 square by 2 plus 10 into 2. This is my upper limit. And the lower limit what happens? Minus 0. If I substitute 0 and 0 over here, it will become 0. Right? So I can neglect this term, which is nothing but 2 and this 2 will get cancelled, 1, 2, and 0.5 into 2 plus 20, which is nothing but 1 plus 20. 21 joules is the work done by the given point of the given equation. Right? So this is how we will proceed with the variable forces. Okay, so like you can ask, sir, you have given that variable force in terms of x. Suppose if they have given in terms of x and y, what we will do? Okay, we will do that also one type of sum. Okay, we will do that sum now. So we have done with this question. Can we go for the next one? The next type. Done. Okay. So the next question. Suppose if they are given in terms of x and y, r, I cap and j cap, both like force. Okay. Now, an object is displaced from a point 1, 2, 1, 2. To B is nothing but 0, 1. So A is 1, 2 to B is 0, 1. By applying a force, F is equals to xi cap plus y, so 2y j cap they are given, 2y j cap. Okay. So find out the work done by F to move the object from A to B. Find out the work done by F to move the object from A to B. Okay. So what I should do now, like many people having a doubt, should I integrate both the terms or what should I do on this question? See, listen, when I talk about the points 1 and 2 and 0 and 1, what is the thing we can understand here? A is nothing but I cap plus 2 j cap, and B is nothing but 0 I cap plus 1 j cap. Right now, this is the thing we can understand over here. And I cap, these points are for x axis, j cap, these points are for y axis, we know. Right now, y axis we know. Now what I should do? What is the thing we should do now? It's easy, right? Yes. So work done will be equals to integral of f dot d s ds. Okay, I won't take dx or d dr anything. ds I will take the displacement. Okay, fine. Now I can rewrite this as work done work done is equals to integral of f of x, like force in x direction dot dx x1 to x2 plus force in y direction dot dy, that is nothing but y1 to y2. That's it, no? So what is f of fx? It is x, and fy it is 2y, and x1 x2 are 1 and 0, 2 and 1. Fine. So let me write down here, x1 is equals to 1, x2 is equals to 0, y1 is equals to 2, y2 is equals to 1. That's it. Now let me elaborate it. This is xi 2y no. So this is from 1 to 0 x dot dx plus this is 2 to 1, that is 2y dot dy. Now integral of x with respect to dx is nothing but w is equals to x square by 2 from 0 to 1, sorry 1 to 0, right? It is 1 to 0 plus 2y square by 2, it is from 2 to 1, 2 to 1. Now upper limit minus lower limit we should do right now. So upper limit is 0, so 0 square by 2 minus 1 square by 2, this is fine, plus low this 1, and this is 2 will get cancelled, no? So y square, 1 square minus 2 square, how much it is now? So this I can cancel it out, and this is minus 1 by 2 plus, and this is 1 minus 4. That's it, na? That's it. So what is the thing? What is the remaining thing? So this is 0.5, that is minus 0.5 minus 3, which is nothing but minus 3.5 joules. So am I getting the correct answer? Yes. Like the negative we got because I am going from the high point to lower point, higher point to lower point, right? So this is the answer, and this is how we will do the problem when they gives in x and y, or if they mention in z also, we can do it. So plus force in z axis with respect to dz. That's it. Okay, you can take a note of this. We'll go for the next question. Done? Okay, fine. So we can go for the next one, and we see the next question, next type. So next type we'll see. Okay, so now what we will discuss is, so the first one we have discussed nothing but work done by a constant force. Constant force. Next one we have discussed is work done by a variable force. So we have discussed problems in both the conditions. Next, one more condition is there. Area under Fs graph gives work done. Okay, so there are three types. Two types we have discussed. The third type is area under FS graph gives work done. So how we can calculate, we will see. Suppose if the graphs is given like this. Okay, this is my force and this is my displacement. Force and displacement, right? So whatever the terms or whatever the graphs whichever we are seeing above the x-axis are taken as positive. The terms which we are seeing in the down, that is down the x-axis, are taken as negative. So positive area, and this is negative area. Okay, and what we will do, I'll add these two things and separate this thing. I'll get the work done. Okay, so for example, if I talk about an object is moving and it has been, the graph has been given like that. Okay, some of the force has been applied. Okay, now let me take this point 0, 3 and this is 6, and this height is given as 2 and here it is given as 1. So what is the work done? This is graph is Fs. So what is the work done? So work done is equals to half into base into height of the first one plus half into base into height of the second one. First one is this one, second one is this one. Okay, so half, base is 3 minus 0 is 3, height is 2 plus, and this is in minus we should take, minus 1 by 2 into base is 6 minus 3 is 3, height is 1. Okay, this is minus 1, right? That's why, like the down thing we will take. Okay, now W is equals to 2 will get cancelled off, 3, and this is 3 divided by 2, 1.5. So minus 1.5 will be given as 3 minus 1.5 is 1.5 joules. So this is my work done by the given graph. So this is how we will proceed the graph problem, proceed the variable force problem, proceed the constant force problems. Okay, so this is how we will find the work done for the three different cases. Okay. Okay, so with this we'll end this session of this today's class and we'll see the next topic in the upcoming session. Okay, thank you guys, we'll meet in the next class. Bye bye.